Hello everyone. We are learning number system in computers, and today let us see the bases and digits of different number systems. Okay, it's very important that we understand this. Base. Now what is the meaning of base? That means the total number of digits in the number system. Okay, total number of digits in number system is termed as base. I hope you understand this. Let's see the first type of number system, that is binary number system. Now binary number system's base is 2. Now you remember what was base, right? The total number of numbers used, and it contains 2 digits, 0 and 1. Okay, that's why the base is 2. Now its base is 2 because it contains only 2 digits. So this is about binary number system. Binary itself, bi refers to 2. Okay, 2 digits. So binary number system has base as 2 because it contains only 2 digits, that is 0 and 1. The next type of number system is octal number system, okay, whose base is 8, and it contains 8 digits, 0, 1, 2, 3, 4, 5, 6 and 7. In total there are 8 digits, and its base is 8 because it contains 8 digits. Okay, I hope you have understood this. Octal itself means 8. Now octal number system has got base as 8. The third type of number system we're seeing is decimal number system. Decimal number system's base is 10. Okay, and it contains 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 10 digits in total. And its base is 10 because it contains 10 digits. The total numbers, right? That's the base. So because it contains 10 digits, that's why its base is 10. And deci itself means 10. The fourth type of number system is hexadecimal number system, whose base is 16. Okay, hexadecimal number system's base is 16. And it contains how many digits? 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Now if you number them total, right, you will get it as 16 digits. Its base is 16. Why? Because it contains 16 digits. Alright, so hexadecimal number system's base is 16. You have to keep this in your mind because in the future we'll learn how to convert these. Let's understand about decimal number system. Now the decimal number system is that number system that is more familiar with us, right? More familiar to us because we use it every day. Decimal is what we refer to as a positional number system. Now this is also known as a positional number system. It helps us to understand the position of every digit. The position of the digits gives meaning to the value they represent. Okay, and the positional number, like for example 10, right? 2 digits are used here to write 10. 0 is in which position and 1 is in which position, right? 0 is in 1's place value, right? That's what we say, place value or positional value, and 1 is in 10's position. So now I hope now you understand about this positional number system, right? That's the reason why decimal number system is known as a positional number system. And the other number systems are binary, hexadecimal, and octal, which we have already talked a little bit about it. These are also positional. So once we understand the theory, the underlying theory of decimal, we can easily apply it to understand the other systems. Now binary, when we talk about binary, base is 2, right? 0 and 1. And hexadecimal's base is 16, which we have already talked about, and octal's base is 8. Right, octal's base is 8. So these are the other number system that we have talked apart from the decimal number system. And once we understand the theory of decimal, we can easily understand and apply the same into understanding the other number systems, that is binary, hexadecimal, and octal number system. So this was a little bit about the decimal number system. Let's see an example to understand it much better. Now, if I have the number 45,689, okay, 45689, what this actually represents? What does this 45,689 represents? Let me just write these numbers once again: 4, 5, 6, 8, and 9. You have learned this in maths, right? I'm very much sure that you still remember it. 9 is in which place value? Okay, I will just write it so that your mind will get refreshed to recall what you have learned before. 9 is in ones place value, right? Ones place value. So 9 into 1. 8 is in 10 place value. 6 is in 100 place value. 5 is in thousands, and 4 is in 10,000 place value. Okay, so we'll just write 9 into 1 plus 8 into 10 plus 6 into 100 plus 5 into 1000 plus 4 into 10,000. Now you see here that every value represents its position, right? And so this positional system can be written this way. Okay, in computer science we write the decimal number systems this way to understand it much better. Let me write down the number 45,689 in vertical form. Okay, 45689. And what we will do is, because decimal number system's base is 10, so we will be multiplying all these numbers with the powers of the base 10, right? Like 10 into 9 into 10 to the power 0, right? Which will be 1, because you have learned about this in maths, that whenever you have a not, that 0 symbol on the right hand side top of a number, it will be equal to 1, right? So 10 to the power naught, or 10 naught, is equal to 1. That is 1 place value. Then 10 to the power 1 is 10th place value, 10 to the power 2 is 100th place, 10 to the power 3 is 1000, and 10 to the power 4 is 10,000. Okay, I will just write it for you so that you will remember it. 10 to the power naught is equal to 1. Any number with a naught will be equal to 1. Alright, so 9 into 1 will be 9. 8 into 10, because 10 to the power 1 is 10. 8 into 10 is 80. 10 to the power 2 is 200. 10 to the power 2 is 100. So 6 tens are 600, and 5 into 10 to the power 3 is 5,000, and 4 into 10,000 will be 40,000. Right, now it's very clear for us to understand the position of every digit, right? Ones, tens, hundreds, thousands, and 10,000s. I will just write all these numbers according to their position in one place so that you can understand its positional values. 40,000 plus 5,000 plus 6,000 plus 80 plus 9. What it represents? It represents every digit's positional values. Okay, and the decimal number system's base is 10. This means we have 10 symbols to represent values, that is 0 to 9. And as we move through each position, what we do? We multiply that number by 10 to the power of that position. The starting position is 0, okay, at the far right side. That's why we are multiplying 9 with 10 to the power 0. Why are we multiplying with 10? Because the base of decimal number system is 10, okay, and we write down the power of, okay, we write down the power of their positions. Let us understand the second type of number system, that is binary number system. Now binary follows the same rule, same pattern as the decimal, except that instead of being base 10, binary's base is 2, right? Binary's base is 2, and instead of having 10 symbols, because binary, we know that the base of binary is 2, and instead of having 10 symbols like in decimal number system, in binary number system we have 2 symbols. Okay, we have 2 symbols, that is 0 and 1. So we'll represent using 2 digits only, 0 and 1, or 2 symbols. So the decimal is a base 10 number system. We have 10 symbols and multiply by powers of 10. It follows like 10 to the power 0, 10 to the power 1, 10 to the power 2. It follows that binary is a base 2 number system, and we have 2 symbols and multiply by powers of 2. Okay, that will be 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, like 2 to the power 0, which is 2 naught, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so forth. But remember that the pattern of binary is same like the decimal number system. Let's see one example to understand it. If I have the binary number 101010, now this is a binary number. You remember that it is represented by only 2 symbols, 0 and 1, right? So I have a binary number 101010. This translates into decimal as, how can we translate or convert it into decimal number system? Let me once again write it in vertical form, right? 101010. So I have written it down in a vertical form, 101010. The left hand side of the binary number will be written top and the right hand side will be written at the bottom. What we have learned, binary represents 2, right? The base is 2. So we'll multiply 0 into 2 naught, right? We have talked about this before. And the next one is 2 to the power 1. The next is 2 to the power 2. The next is, I'm sure you know it, right? 2 to the power 3. Very nice. And the next is 2 to the power 4. And the last one here would be 2 to the power 5. Very well. Now let us simplify it, or let us solve it. There is one thing I want you to remember, that anything to the power of 0 is always 1. I have told you this when we were understanding decimal number system. You remember this always in your mind, okay? Anything to the power of 0 is always 1, which is also termed as naught, right? In mathematics we have learned this. Like 2 naught is equal to 1, 15 naught is equal to 1, or it can be 1056 naught is equal to 1, even 10 naught. Translating the binary number to decimal number system. As we're translating binary number to decimal number, any number which you multiply with 0 will be 0, right? 2 naught is 1, but 0 into 1 will be 0. 1 into 2 is 2, and 0 into 2 to the power 2 will be 0. 1 into 2 to the power 3, 2 to the power 3 will be how much? This means that we have to multiply 2 3 times. Okay, let me just help you understand it here, which is also termed as 2 cube. Okay, 2 into 2 into 2 will be 8. So 1 into 2 cube is equal to 8. Any number with 0 will be 0. Now the last one is 2 to the power 5. This means we have to multiply 2 5 times, and when we multiply 2 5 times, how much will we be getting? 2 to the 4, 4 to the 8, 8 to the 16, and 16 2s are 32. And so 1 into 2 to the power 5 is equal to 32. What is our next step? We will add all these values that we have found. Okay, so we have written down the addition of these numbers. 32 plus 0 plus 8 plus 0 plus 2 plus 0 will be equal to 42. So what we have done here is we have translated or converted binary number 101010 into decimal. So in simple sense, the binary number 101010 will be equal to decimal number 42. I hope you have understood this. We'll be learning more, and you can go back through the video and see it again to understand it much better. So keep learning and keep studying.